Hello everyone and welcome to my poster presentation. Today I'll be talking about our work on development of a biodegradable piezoelectric scaffold for bone regeneration. So if you look at the first column over here, we present a new tissue stimulating approach using a piezoelectric PLA nanofiber scaffold in combination with a non-invasive ultrasound treatment. We fabricate our scaffolds using electrospinning, and since they're nanofibers, they offer an excellent ECM-like environment for bone regeneration. So the electrospinning machine that we use to fabricate our scaffolds has a collector drum that rotates at a number of speeds ranging from 300 to 3000 RPM. And as we increase the rotation speed, the alignment of fibers inside the scaffold changes. So as you can see in the 300 RPM scaffold, the fibers are aligned pretty randomly, but as you increase the speed to 3000 RPM, the fibers get more and more aligned in a single direction. We also tested the piezoelectric output of the different scaffolds, and what we saw was the 3000 RPM scaffolds had the highest piezoelectric output out of the 3 scaffolds that we tested. Next, we tested the ability of our scaffolds to induce osteogenesis in vitro, and we used adipose-derived stem cells for this purpose. And these are the different groups that we tested. So we quantified the alkaline phosphatase produced by the scaffolds and the mineral formation by our scaffolds. And in both cases, we saw that the scaffold, which was piezoelectric with ultrasound treatment, had a much higher ALP formation and mineral formation as compared to all the other groups we tested. Now, if you look at the second column over here, the second set of tests we did in vitro were RT-qPCR to look at the expression levels of osteocalcin and osteorix. And once again, in both cases for both genes, the scaffold that was piezoelectric with ultrasound had a much higher gene expression than all the other scaffolds. Next, we tested our scaffolds in vivo using a murine calvarial defect model. And these were the 4 groups that we tested. And we saw that the piezoelectric scaffold with ultrasound had a much higher bone formation than all the other groups that we tested after 4 weeks of ultrasound treatment. So in conclusion, we present a novel tissue stimulation approach using a biodegradable PLA nanofiber scaffold in combination with non-invasive ultrasound, which enhances osteogenesis both in vitro and in vivo. And we look forward to using this technology to regenerate other tissues like nerve, cartilage, skin, and muscle. Thank you very much for listening to my presentation, and I will be happy to take any questions.